If you think about AI, everything is still an API behind the scenes. We like to think that we've moved past these operational and infrastructure concerns, but we actually haven't. It's just much more hidden away from us. It's also creating another problem where folks can just go off the shelf and consume things, if you will, an MCP server, consume different agents, forgetting the very basics of security, which is what an API gateway is there to offer.
Hello, everyone, and welcome to another episode of the Modern Web Podcast. I'm your host, Danny Thompson. Today, I'm joined with a very special guest, someone who has become a very good friend. I love a lot of the work that he's been doing. Super excited that he was able to join us today. I'm with Marino Wijay. Marino, what's going on?
What's going on, Danny? Happy to be here. There's so much we can talk about today, right?
Yeah, I feel like we're going to touch on a lot of things. I think we're going to touch on, to kind of summarize some of it, we're definitely going to talk about security and APIs. We're going to talk about a lot of work within the cloud sector. We're going to talk about a lot of work with AIs, and we're going to talk about some community work. And so for those that don't know, Marino is the staff solutions architect at Kong. And on top of that, he is an amazing advocate in the space. I've seen him do so much work. He was also part of Commit Your Code last year. That was a huge plus for us. But on top of that, he's constantly giving back. And so maybe we can kind of jump into that aspect first and kind of start pulling back a little bit. And so, as a CNCF ambassador, how do you decide what projects to champion, what projects that you want to be a part of, and how can people that are listening to this even start getting involved with that?
So a lot of you might probably know me for my Kubernetes and networking chaos that I speak about quite constantly. If you're someone that's trying to get involved in this cloud native ecosystem, the first thing you have to do is understand what Kubernetes is and what it's doing for you. In that ecosystem, you're past that development stage, and now you're trying to operationalize all these different applications you've developed. And for someone that's just trying to get into this space, understanding how Kubernetes works is probably going to be one of the biggest assets that's going to help you get involved in the community, be a part of it, and even start to connect with so many people in this ecosystem. So a little bit about that CNCF ambassadorship, what that means. It really comes down to taking what you know, your years of experience, and then reflecting that back into the community. You've learned so much about Kubernetes, you've learned so much about networking, maybe you've worked with a bunch of technologies, and now it's finding a translation layer so that you can bridge that gap from old to new. So a lot of the stuff that goes on in the cloud native ecosystem has been done before. It's just been done in different pieces and different parts. And now that CNCF ecosystem is really about governance. How do we tie this all together so that it becomes repeatable for a lot of organizations, a lot of companies to take and run with? No one wants to just go and deploy Kubernetes open source. They want to deploy it with the right guardrails in place. They want to have the right security practices in place too. They want to be able to automate. They want to leverage things like continuous integration, continuous deployment. They want to take their code that they've stored up in Git and deploy it very easily in a very automated sense too. So someone that's just breaking into this space. Okay, you've learned Kubernetes, you've learned some of the ecosystem technologies that really help you, make a productionized Kubernetes ecosystem and system work. The next step is turn it around and share that with the world. And that's what I've been doing for many, many years, probably the last 4 or 5 years now, where I've taken the best of what Kubernetes has to offer. I've taken the ecosystem and just relate it back to so many people so I can get them along their journey too. That CNCF ambassadorship, that cloud native ambassadorship is really about driving the community not to just consume more. It's not just about consumerism. It's about educating them and sharing a lot of your learnings from where you failed, what you've attempted to make successful, and where you went wrong, how to just avoid those pitfalls. And then also doing community things too. So for example, late last year, actually probably mid last year all the way to late last year, I was doing a lot of X spaces around different cloud native projects. For example, we'd have folks come up and talk about open telemetry, which really gives you a lot of observability into your applications and how they're performing, and even the associated infrastructure that they're tied to. We had folks come up and talk about security. We'd have folks talk about networking. We'd have folks come up and talk about specific new features that are popping up in the ecosystem altogether. And that's just amplifying particular projects, if you will, about what they do, how they can just help your organization move along. Now, remember, all of this is open source, right? So you could just go in there, pick a project, and advocate for it, evangelize about the product, if you will. There's also the other side to it too, where projects need love. They need some curation. They need to be better not just by like better features, but also better docs. Sometimes the communication side of a project is so weak because you got a project out there, it does some great things, but no one talks about it. No one talks about what's really good about it. And so that's why we exist. We have ambassadors that cover a wide array of specialties. We have ambassadors that organize events. They run meetups. I run a meetup too that's in Toronto. We have last year we did 4, and this year surprisingly we're doing many more, probably almost double that. And it's because there's just so much interest. People want to get together. They want to hang out. They want to learn from some of the stories of what people are doing in production or before they get to production. And they also want to hear about the updates too, because sometimes having to comb through a bunch of documentation isn't ideal. Coming to an event where you get to meet people and connect with them and hear about some of the latest and greatest is probably the best way people learn at times. So that's what it means to be a CNCF ambassador. If you're interested, you already missed the deadline for the application because it was June 30th. But don't be sad, because there's going to be another round that happens later on this year.
That's awesome. And I'm being honest, I like that. Obviously, meetups are very near and dear to me. I think this year alone, I'm on track to do 36 this year, so it's quite a lot of meetups. Yeah, I mean, this is adding in what our regular group does. I'm over 2 meetup groups in Dallas, and so both groups are doing meetups. But we also do now pop-up meetups whenever I'm traveling. So that's been pretty successful for a lot of people and bringing a lot of value. We just did one in New York, and that New York one, man, the room was packed, which was awesome. Which, obviously when you go to a town that's not yours, you sometimes wonder, are people going to actually show up because you don't have, a pulse on things. And so for even regular New Yorkers to be like, man, this room is, really packed, I was like, whew, we did justice to the effort. And but, of course, anytime we do a technical meetup, it's always online as well, right? So we had some good crowds for the online one. Regardless, let's kind of jump back into a couple things in particular. And so obviously, with the meetups and stuff kind of on the side, you do a lot with your organization, whether it's educating on best practices, whether it's working with companies to make sure they're using the right tooling and things like that. And so I'd love to get your perspective on some of this. And so maybe some people aren't necessarily familiar with some of the things that we're going to be talking about today. So maybe in your view, what is a core distinction between an API gateway like Kong Gateway and a service mesh like Kuma?
Yeah. So everyone builds APIs. They don't really just think too much about it. You will build something with Python or JavaScript or whatever. If you're using Python, for example, you might use Fast API and develop a set of API endpoints that if people are working with your application or trying to communicate with it, they're going to hit every one of those endpoints to get some data or maybe even modify parts of that application if they need to. But if you are just presenting this on the internet, well, you're not really doing yourself a service, because you are starting to get to this idea of, okay, I've got my product out there, it's got these API endpoints, you can consume it, but you're not protecting yourself. You're not protecting your APIs. You're not scaling your APIs as demand hits. So the classic example that I think a lot of people will think about is Black Friday hits, or Boxing Day if you're in Canada. And a lot of websites that sell stuff, especially when you have sales, their traffic goes up substantially. And when that happens, you also need the systems behind those websites to scale up as well, because you've got a front end that is communicating to a back end API, and all of that needs to scale together when that demand peaks. But the other side of that problem, though, is that you can't scale infinitely, and you can't scale for whatever reason. And the reason why that is because you might be in a situation where you're subject to something called a denial of service attack. So you've got all these APIs. Some of them are exposed. Some people publicly can consume them, but you need some security around those APIs. So you need to think about maybe using some sort of token, or maybe you're using an API key that you're sourcing from a website. Maybe you're using OpenAI's API, and you need to get an API key from them. Now, they protect this, they safeguard this, they safeguard their API as much as they possibly can, because they don't want to run into a situation like a denial of service attack. So where Kong comes in, or similar companies when they offer up an API gateway, is that you've got this proxy that sits in front of your API or your API endpoints, and it's applying different kinds of policies, it's enforcing these policies, it's enforcing things like a rate limit so that you can only do a certain number of requests per second or per minute. You're also triggering some things in the back end where if there's a sudden spike in demand, well, we can gracefully scale up without just scaling up, because we also don't want to infinitely scale. If we infinitely scale, we also have problems of our AWS cloud bill being ginormous, which is something we're trying to avoid altogether. But that's where an API gateway really comes in. Now, the API gateway is the front door to your API, to your fast API, to your Python application that you've developed. On the back end, you might have a bunch of different services that communicate with each other. So you might have this set of microservices. You might have 5, 10, hundreds, whatever you might have. You might have this mobile application that you're running, and you've got a front end that's presented on an iOS or an Android phone, and the back end is just comprised of so many different microservices. So you might build in a microservice-like pattern because you don't want to change your entire application stack all in one go. You don't want to have to do that recompilation, because recompiling takes a heck of a long time, especially if you don't have a system that's powerful enough to be able to handle something like that. So you want to be able to, in smaller pieces, smaller chunks, update your application. This is where a microservice comes in. So maybe you're just updating a small feature, and maybe you also want to release a newer feature to a smaller group of people. So this is where a service mesh comes in, right? Now, you can also do this with an API gateway, except you're thinking in patterns. And if you're thinking in microservices patterns, a lot of this is not externally exposed. But let's just say you've got a service that needs to talk to another service and a newer version of that second service. A service mesh like Kuma really helps you navigate the traffic between those two different versions, so that you're maybe sending your traffic to both versions, but in a split. So you've got 90% of your traffic going to your original version, so you're not breaking things, and that 10% is very limited, but you're also testing for functionality. You're testing to make sure it works the way you intended it to. Maybe you even have to think about authentication for a second, because when you're transacting between different APIs, you don't want them to freely transact. You need them to have some sort of authentication in place so that there's some verification that goes on. This is where service mesh comes in too, because it'll help with that authentication. But then, oh, by the way, what about things like TLS, transport layer security, where I, as a consumer, might be going to a website that's HTTPS backed, and all my encryptions from my client up to that system, that website, is encrypted. Well, the same thing has to happen for microservices. You need to have that level of encryption. So the best way I've always framed this is your API gateway, Kong gateway, for example, is the front door to your application. Whereas something like Kuma, which is a service mesh, sits between services and allows for service-to-service transactions, authentication, encryption, security, if you will, so that you prevent situations like I've got a set of developers that have free reign access to an environment where they just deploy, and they might just pull a container down from the internet, not really thinking about where it came from, its originality, whether it's been authored by a legitimate source or just something they pulled off the internet. And now you've got a service mesh that comes in and protects your application environment to prevent like an outage or maybe some sort of vulnerability that gets exposes itself to some of the other services that you have. So that's really what the differentiation is. these are enterprise systems that really work in large organizations. You might be a smaller organization, you'll start off with an API gateway. And as you scale, maybe you need a service mesh.
I love the distinction. And so, I mean, if, let's say, somebody listening is on that smaller side, maybe it's an independent person that's trying to build up a practice. Maybe it's a small team of 5 or 6. Like when I was at the AI Engineer Conference in San Francisco, one of the most attended tracks was tiny teams. Like there are smaller groups now that are trying to really compete with some of these bigger organizations now. So if it's a tiny team or a small organization, what are some of like the best practices that you could recommend that they think about or implement when they're integrating like an API gateway into their organization?
A lot of teams, smaller teams especially, shouldn't try to do everything. They shouldn't try to implement a service mesh right off the gate, because that just adds a layer of complexity and a lot of tracking. You have to manually track what you're doing, what you're building out for your microservices patterns. In fact, what you find with smaller teams is that they tend to run more managed services or hosted services. So a good example is like Google App Engine. You'll probably run App Engine because you don't want to have to sit there and manage infrastructure, but you want some level of control of how your app looks in the cloud or out there in public. And then you still might implement an API gateway because while you've got this application that's doing a number of different things, you might have like partners, or you might have consumers, you might have maybe different applications that sit outside of that particular one that need to transact with that API. And you don't want to just freely transact with it. It's like I said earlier, you want something that's a lot more secure. So what I find smaller teams doing is they'll use managed services as much as they possibly can. They'll shy away from and not necessarily try to sit there and think about like how to run Kubernetes at scale. That's not something for small teams, because when you think about it, you've only got so many hours in a day, and you don't want to spend 40 hours in a week trying to like get a Kubernetes cluster up and running. Now, if you've already got the expertise, that's a different story, because you probably have managed clusters before, you know the inner workings of one, so you're okay using a managed Kubernetes service, for example, and you pair that with an API gateway because you still need a way to bring your traffic into your cluster. You still need to secure it with HTTPS or TLS, if you will. You still need to do that authentication bit as well. You still need to do a whole bunch of things like rate limiting regardless. So you'll always have one in place, because we're in the world of APIs today. Like if you think about AI, everything is still an API behind the scenes. We like to think that we've moved past some of these operational and infrastructure concerns, but we actually haven't. It's just much more hidden away from us. Except it's also creating another problem where folks can just go off the shelf and consume things, consume, if you will, an MCP server, consume different agents to do different things for them, without forgetting like the very basics of security, which is what an API gateway is there to offer. So anything you do these days, you're going to be transacting with an API. And if you're building with APIs, you're probably going to need an API gateway anyways to help you scale up your APIs, secure them, lock them down in different ways, and just enable your transactions to be a lot more safer.
Love that. Cool. So moving on now, like we kind of talked about microservices, for example. And so with microservices increasing in complexity, as we even discussed, how do you approach designing a gateway for reliability or observability? What are some concerns that somebody should have, but what are some things that doing XYZ kind of alleviates a lot of those concerns?
When we're thinking at scale and we're thinking like large organizations that are consuming microservices, Kubernetes, API gateways, mesh, whatever it is, it's less about standing up infrastructure and it's more about your operational patterns, your policies within your organization, and automation too. Like how much you automate, and at the same time how much you custom automate, and I'll get to that in a second, is what's going to improve the overall experience. So when you think about a team that wants to onboard an app into your platform, which already runs Kubernetes and an API gateway and mesh and whatever else, the best thing you can do for them is give them an ultimate and amazing developer experience. You present them with an input form, and the rest gets automated, right? I want my application name to be this. Here are the teams that need access to this. Here are some of the parameters I need to think about because this is how many transactions I might incur in a given period of time. And oh, by the way, here are my container images, or here's how I built my container, or maybe even here's where my repo is, where my code is stored. So now you've got an automation system that runs pipelines. These pipelines are doing a number of things. They're reading in the Git repo, GitHub, for example, and then they're taking in that configuration. Then they're effectively containerizing your application for you. So they've got like some sort of GitHub runner that's doing this activity. A runner is just, in effect, like an operating system that's got some sort of containerization capability or compilation capability, if you will, that does all of that work for you and then outputs some sort of image. And now you've got an image and you need to run that image somewhere. So now you've got another pipeline that provisions infrastructure to run that image. And then you've got another pipeline to wrap around all of your guardrails as you need to. And then you've got a pipeline to publish that out into the public internet or to your internal teams as well. And all of this just comes back to automation. So you might combine a little bit of Python with your Flask app with Terraform. Some of you might have heard of Terraform before. It's just an infrastructure as code tool. But you have a system that acts as a human in a lot of ways to run through these different steps to give you something that's in production, to basically push something to production or close to it, if you will, because there's always that final step of, hey, I approve of this, and now we can actually move this into production because, oh, by the way, this is going to impact 100,000 people or maybe a small team. It doesn't matter. But that automation and that stitching that has to go on behind the scenes needs to happen first before you can have this nice fluid system that goes from code to production.
All right. So, one thing that we talked about, especially before we started recording, is how you're working with a lot of clients right now, especially in regards to their AI rollouts, adoptions, how they're utilizing it. And one big thing that, obviously we've seen with LLM traffic is how much you're driving it at scale, right? And so what are some best practices that you've seen for managing LLM-driven traffic at scale, especially regarding vector caching or maybe even cost optimization? Because some of this stuff can really ramp up bills if you're not paying attention to it, especially when we're talking about tens of thousands of users to millions of users. What are some considerations around that?
Yeah, this is a very interesting question because what we're in the world of right now, where we are today, is that everyone wants to use AI. Everyone wants to use an LLM. What will happen is let's go to Gemini for a second. Let's go to the Gemini playground and let's go source an API key. Yeah, it's attached to a Google project. Sure, that's fine. And someone's tracking it somewhere, right? But now I've got that API key that I own and I can pair it with my application to go call an LLM when it needs to run some sort of function. The problem is between your application and Gemini, there's nothing in between. There's no governance. There's nothing to protect your outbound calls to that LLM. And what happens is that LLM now stores that data. It's storing it unless you actually go in and turn it off. But one problem with that is if I'm doing it and now 5 of my peers are doing the exact same thing, running the exact same code to call that LLM, what I've just effectively done is done the same thing 6 times over for no reason. So when you're talking about cost control and this whole vector caching in one bit, what I've seen a lot of providers do is now they'll start to cache queries or prompts as well as responses and return those as answers instead of having an LLM actually compute what you just sent as a prompt. Now, while they're doing it too, you're thinking about just a single provider that's doing this. So OpenAI might do this, or Bedrock might even do this as well, AWS Bedrock. Now, on the flip side, if you want to have more control of that, enterprises are now looking to API gateway technology to solve that problem. So Kong does it. Kong's got something called the AI Gateway, and effectively, what Kong has developed is this capability to target the different LLMs and providers and models that you're going to and implement policy. So that policy might come in the form of, all right, if I send out a prompt and someone's already asked about this prompt, let's go to cache. Let's go to cache and pull that response and send it back to the user or agent or whatever it is. Because why would I send it to the model for processing? I'm just going to consume more tokens, which translates to credits. That round trip token is maybe not significant in 1 or 2 calls, but when we add up those calls, well, it adds up to the number of credits we chew up. So if we start caching a lot of this stuff now, okay, we're saving money, but we're also cutting back on latency, especially if we have some sort of latent sensitive applications. That latency, that round trip time to go make that request and then get an LLM to respond to it adds up. And then it just creates a bad experience for the user. So using caching mechanisms like a vector database, Redis is one, for example. There's so many others out there. pgvector is another. Effectively cache those queries and stores them as embeddings. And then based off of some similarity index, we'll evaluate for similarity. And if something seems very similar to you, we'll return that data back to you. But that's just like one problem of what's going on with AI and consuming these LLMs. There's another problem. Someone will take like an entire email and shove it into ChatGPT and be like, summarize this for me. And what they may not think about is, well, what about the PII I just threw into that chat window, the personally identifiable information? It's a problem. I'll stop there. You came off mute. I think you have something to say.
Because you're exposing me, bro. No. I usually redact anything PI. Like I'm a big one that I have a hard time sometimes judging my tone when it comes to emails or someone else's, and so I generally try to catch that via like an LLM model to make sure like my tone is accurate. But I'm curious that you said 2 things, and you were going down this rabbit hole. So I wonder if like this is tied to this in regards to caching, right? Like, what are you recommending? Like, is it like 30% that you're trying to cache, 40% you're trying to cache of the responses? Like, what are you trying to cache effectively to kind of save, I suppose, as far as like latency and experience? But the other aspect is in regards to like PII. Like, isn't there certain guardrails that we could have in place to where if a customer is putting this into a certain degree, like we're able to omit some of that? But also, I guess the way that I'm trying to word this is obviously, how much are we trying to cache in this regard? But I think the other thing too is like, if we have people that are putting in big contexts of emails or blog posts or whatever it may be, like, are there certain measures in place that can help mitigate some of those costs, or is it just going to be like you have to bite the bullet because that's what the customer put in?
So when it comes to how much we actually want to cache, right, that's going to be entirely dependent on what our application or what our agent might be doing. If we let's think of let's say a call center agent for a second that is making outbound calls or receiving inbound calls, and they obviously just don't want to read from a script all the time, but maybe they want to actively answer a question. And sometimes maybe it's not ideal to just, go look up some documentation, have someone wait on the line until you read through everything. You can ask a model to do that for you. Now, what's interesting and what we're seeing as a pattern is you're using a local LLM, a local model that you stored, within your data center or maybe in your cloud environment that you have access to, that is processing your documentation and can quickly provide your responses. But even from that standpoint, if you have like 100 agents, 100 call center agents that are calling outbound, chances are like maybe like 80% of them are, I don't know the actual figure, but I'd estimate about 80% of them are effectively asking a model the same thing. They're asking their docs the exact same thing, and they're looking for a response. Do we actually need to go to the actual model to process that information? Probably not. We can just go to cache because there's probably a cached response that's very succinct, very to the point, and directly addresses that end user or consumer's question about, can I get this in my Chevy Corvette or something like that, as an example. But when you think about that PII side of it for a second, right? if we're just dumping in user information into a query and sending it off to a model, something has to catch that. Something has to either redact it or jumble up the information, because the last thing you want to do is a public model consuming this data and storing it somewhere, and then guess what? Like 5 years down the road, there's a breach and no one has changed their, I don't know, user ID and password for whatever reason, because maybe you're me and you like using the same password over and over and over again. But in that situation, maybe you need a PII sanitizer that comes in, looks at the request, and identifies a credit card number, a social security number, a password, a phone number, if you will, maybe an address, and changes it up or redacts it so that the LLM doesn't actually need that information. They just process the data around it and then gives you a response based off of that. So organizations are starting to take on and adopt these particular methodologies. In fact, you even have organizations that are cutting off access to chat engines like OpenAI's or ChatGPT, if you will, just to push users towards their local chat engines. And for good reason, obviously, right? Like we can't just simply allow everyone to go in and dump in a bunch of data and get ChatGPT to process it for us. We need to be a lot more intentional when working in our professional setting as well. And sometimes we as users, myself included, we're not the best at following rules within an organization. So sometimes you have compliance and governance within an organization that comes in and disallows these processes, not just by telling you can't do it. They actually have systems in place that block your access to ChatGPT or something of that nature, but give you an alternative, right? For example, if you're using VS Code and you've got Copilot running, chances are you're a developer that's doing that today, which is completely fine, right? Copilot's great. It helps you with a lot of great information. There's another one out there, Windsurf is another great one that allows you to tap into different models. But there's an option to use a custom local model too, where you might be using LM Studio and serving up a model you downloaded that's offline. And when you're in VS Code editor or something of that nature, something similar to it, it goes back to the local model and then gives you information. Now, not everyone can run a local model. Not everyone's got like a high-powered MacBook Pro that can do all of this for you. And so they have to rely on a cloud system. And this is where organizations are coming in and saying, hey, we'll buy up GPUs, we'll run our own data centers, we'll keep this data local, and we can reuse this data somehow else later on to maybe improve our processes as well. But at the same time, let people use tools like VS Code like they've always been using. Just point your model to something that's local now, and we'll maybe gray out all the other options because you're not allowed to use them. And that's what I'm seeing as a pattern, right? They're really trying to govern AI usage within the organization, not because they don't want people using AI. In fact, I think a lot of organizations are encouraging people to use it. They just have to be a lot more considerate and concerned about how they allow their end users to go about doing so, because of the implications of maybe leaked intellectual property. That's a big one that's been happening, right? Someone will talk about an idea or maybe put it up as an issue on GitHub, and then a week later, someone has developed a product around it, right? So you start to see a pattern of let's use tooling and compliance and governance to protect our IP even.
I'll be honest, Marino, we've covered a lot today. This has been pretty incredible. For those that want to kind of get connected with you, learn more, maybe attend some of the talks that you've been giving out, or see what you're involved with, I know we're going to have your social links in the show notes, so in the description down below or wherever you're listening to this, you'll find links for Marino. But where can people find you?
I am mostly trolling around on X. You can find me here and there. Just look up my name and you'll find me very easily. But I'm also on LinkedIn. So if you also want to connect with me there and see some of the more professional stuff that I do, some of the thoughts that I share about what we're doing in this industry, or even catch some of the live streams that I do around AI, you're absolutely welcome to come tune in. We do those. We try to be weekly, but right now it's been bi-weekly only because we're just so busy with so many other things going on. But those are the two best places to come find me. And maybe I can make your code too.
Hey, I'm not plugging, but I'll say so. If they want the bouldering, silly goose side, they can go to Twitter or X. They want the professional side, LinkedIn's where it's at. All right, y'all. And that's it for this episode. I'm Danny Thompson. I'm D Thompson Dev on all social media. You could also check out RoboCell, who is RoboCell on Twitter and all the social media as well, who's normally here, but today, unfortunately, he's not with us because he's enjoying a vacation, and I'm jealous. So, and one last thing I need to share, obviously, that this episode was brought to you by This.Labs, and they want me to remind you that they are experts in modern web development and consulting. And if you're looking to scale up your development teams efficiently or need assistance in turning your innovative ideas into a reality with robust proofs of concepts, This.Labs has you covered. This.Labs doesn't just build software, they build partnerships. They collaborate closely with your team to understand your unique challenges and craft tailored solutions that drive real results for you. Join the many companies that have accelerated their growth with innovation with the help of This.Labs. Visit this.co to discover how they can help you take your projects to the next level. Thank you to This.Labs for sponsoring this episode and for supporting the developer community. And that will be all, y'all, and we'll see you on the next one. Goodbye, everybody.